Online class. In last class, we discussed about alcohols and phenols. Along with that, we discussed about the classification of ethers and the naming of ethers. So we know what are ethers. Ethers are the compound which having OR bond or OR functional group. So in today's class, we are going to discuss about how to prepare ethers. For that, we'll see how to prepare ethers. For this, for the preparation of ethers, mainly there are two methods. First method is dehydration of alcohols. From alcohol we can prepare ethers. And the second type is Williamson's ether synthesis. So let's see one by one. So first method is by dehydration of alcohols. What do you mean by dehydration? Dehydration is removal of H2O. Hydration is adding H2O. Dehydration means removal of H2O. That is water. So from alcohols we can prepare ethers. But there are two types. If there is excess concentrated excess acid, the alcohol will give ethene, alkene. But so we have to use the acid in a limited method and in the given temperature. So dehydration of alcohols results alkene or ether. So we have to use the condition for 413 Kelvin, then only we will get our ether. So from alcohol we can see that there is the elimination of one hydrogen from here, and we'll get the elimination of H2O will get our ether. So by the dehydration we'll get ether. We can see here. The next method is by Williamson synthesis. This is known as Williamson's ether synthesis. It is by the nucleophilic substitution reaction. So we know what is nucleophilic substitution reaction. It is a biomolecular nucleophilic substitution reaction, SN2 reaction. So by the attack of nucleophile, we'll get the product and we'll get unsymmetrical ethers. By this process, we know what is symmetrical ethers and unsymmetrical ethers. So for this process, the haloalkanes, we know what are haloalkanes. Haloalkanes are treated with sodium alkoxide, which produce unsymmetrical ethers. Here we can see the mechanism. What is the mechanism is the sodium from the alkoxide and halide will eliminate. This sodium halide will get and will get the unsymmetrical ether. So for primary alcohol, if according to the alkoxide we'll get different ethers. If it is primary, we'll get like this ethers, chain ethers, and if we take the secondary alkoxide, we'll get a different branch type of ethers, etc. We can synthesize this reaction. So let's see the mechanism. So we know the alkoxide part. If we take the haloalkane, CH3 having plus charge, bromine having minus charge. So we know the in alkoxide, the oxygen which carrying lone pair of electron, that is negative charge, which will attract the positive charge. So the bromine will eliminate. Similarly, the sodium will eliminate from here. So we get the product. Here you can see an example. Then from primary haloalkane we can make ether easily. If we take secondary and tertiary haloalkane, the elimination reaction occurs them rather than the substitution, rather than elimination will favor in secondary and tertiary. So it will produce alkene rather than ether. So for the easy method we are using primary haloalkane. And from phenol also we can prepare ether. If phenol is treated with sodium hydroxide, we'll first form sodium phenoxide. This is sodium phenoxide. The second one is sodium phenoxide. Then this sodium phenoxide we are treating with haloalkane will produce the ether, which is alkoxybenzene. So these are the example. And we'll move to the chemical reactions of ethers. They are very less chemically reactive. They do not undergo oxidation and reduction. And we studied in alcohols and phenols, they will undergo oxidation, reduction, and they will react with active metals and all. But ethers are less reactive compared to alcohol and phenol. But it will carry out some reactions with strong acids. In drastic conditions only, they will undergo the reactions. So two types of reactions are there. Reactions involving cleavage of CO bond. We know in ethers there is direct carbon oxygen bond, and electrophilic substitution reaction occurring in aromatic ring. So let's see the reactions involving cleavage of CO bond. So if we check here, we can see we said in drastic conditions only these reactions will occur. So a mixture of ethoxyethane, that is diethyl ether, and dilute sulfuric acid is heated closed vessel under pressure. So this is the drastic condition. Heat and closed vessel in under pressure. So which will produce alcohol. So from ether we can produce alcohol. This is one type of reaction, that is this CO bond will break. Then OH will attach here. That is also dehydration. Then reaction with hydrogen halide. So if we treated it with hydrogen halide, it will produce haloalkane. You can see haloalkane will produce here. That is the other type of reaction. Then it will undergo electrophilic substitution reaction. This is in the case of aromatic ethers. That is, we can see nitration, bromination, that is nitration, bromination, chlorination, all are occurs here. That is in anisole. This compound is known as anisole. And in anisole, if undergo the nitration, it will form ortho and para directing, that is ortho and para nitro anisole. You can see here, either it will be the ortho or para. And bromination, similar to nitration, will get ortho and para anisole. Then another reaction is Friedel-Crafts alkylation. That is, alkyl group is substituted here. Alkyl group is CH3 group. So Friedel-Crafts alkylation is in the presence of CH3Cls and anhydrous AlCl3, that we discussed. The Friedel-Crafts alkylation and acylation we have discussed in haloalkane and haloarine. So if you check here, if anisole is treated with CH3Cl in the presence of anhydrous AlCl3, the CH3 group will introduce here. That is also ortho or para compound. So we can call it as ortho methoxytoluene and para methoxytoluene. And Friedel-Crafts acylation, that is acyl group will introduce. That is CH3 COCH3 group will introduce. That you can see here. Similar to alkylation, COCH3 group will introduce. And there are some organic conversions which these ethers are producing in this. These are not in our syllabus. And we'll discuss the physical properties of ethers. These are about the chemical properties. And if we discuss the physical properties, The phenols are having low boiling point compared to the alcohol. Why? Because alcohol having intermolecular hydrogen bond, but ethers does not having intermolecular hydrogen bond. So compared to those, ethers are less reactive and less boiling point having for these ethers. These are about the ethers. And for equal molecular mass contain alcohols and ethers, ethers have lower boiling point compared to alcohols because ethers does not having intermolecular hydrogen bond. So, but alcohol having intermolecular hydrogen bond, so they are having high boiling point. In order to break this bond, we need to supply more energy. And the structure of our functional group we have discussed already. Then this about ethers, and it is less soluble in water compared to alcohol. We know alcohol having hydrogen bond, so it have the ability to make hydrogen bond with water, but ethers does not have this ability to make hydrogen bond in water, so it is less soluble in water. So I hope all of you understood this topic. So from tomorrow we will start a new chapter. Okay, thank you.